At the point when you look at the immense field of the universe, with its planets, stars, and systems, one key inquiry brackets for a clarification: why would there be something as opposed to nothing? The mystery extends when we consider the evenness of the laws of physical science overseeing our universe, which appear to treat matter and antimatter similarly. Yet, upon perception, we track down that the stars and worlds we see are transcendently made of matter, with antimatter barely present. This drives us to consider the multifaceted powers that organize the lopsidedness, giving ascent to the world as we see it. What significant systems influence the situation, conceding us a universe overflowing with worlds, stars, and the secret of our own reality? How did this incredibly immense universe appear? For hundreds of years, researchers accepted the universe to be timeless and perpetual, represented by the permanent laws of material science. Anyway, in 1927, a Belgian minister and researcher named Georges Lemaitre proposed an alternate thought. He recommended that the universe began as an enormous, pregnant primitive iota that detonated, giving birth to the more modest iotas we see today. Despite the fact that Lemaitre's thought initially got little consideration, in 1929 cosmologist Edwin Hubble found that the universe isn't static, however, it is, in truth, growing. This disclosure drove some researchers to conjecture that, assuming we were to rewind the universe's set of experiences, it would contract back to a little, thick point. This idea was jokingly named the theory of prehistoric cosmic detonation by cosmologist Fred Hoyle, a name later embraced by its advocates. Unfazed by wariness, researchers Ralph Alford, George Gamow, and Robert Herman anticipated that if the Big Bang had happened, a weak phosphorescence ought to pervade the universe. In the mid-1960s, cosmologists Arno Penzias and Robert Wilson coincidentally found this inestimable microwave foundation radiation, the reverberation of the huge explosion, while endeavoring to tune into microwave signals from the Milky Way. If the theory of the universe's origin turns out as expected, how could it lead to the arrangement of planets, stars, and cosmic systems? Through fastidious estimations and perceptions from telescopes on Earth and tests in space, our best clarification arises: roughly 13.8 billion years ago, all the matter in the universe ejected from a solitary microscopic place of peculiarity in a fierce blast. This extension happened at an amazing rate, multiplying in size every /10⁻⁻34 seconds, making space as it quickly expanded. Inside a negligible part of a subsequent, gravity and other crucial powers framed, and energy changed into particles of issue and antimatter, the majority of which obliterated one another. Luckily, some matter endured, giving ascent to protons and neutrons. Inside the first second, these particles began to intertwine, shaping hydrogen and helium cores. Close to 300,000 years later, iotas began to shape as cores caught electrons, filling the universe with billows of hydrogen and helium gas. Roughly 380,000 years after the starting blast, the universe left behind a leftover shine of infinite microwave foundation radiation, which Penzias and Wilson fortunately recognized. Inside this radiation were microscopic changes in issue extended to grandiose scales during expansion, which at last filled in as the seeds for the development of cosmic systems and cosmic groups as we probably are aware them today. Today, when we overview the limitlessness of the universe, our thorough perceptions, in spite of inherent vulnerabilities, reliably highlight an intelligible account. Our universe includes matter and complies with the perpetual laws of material science across all reality. It works under the umbrella of general relativity, extending, cooling, and floating with its elements impacted by dim energy and dim matter, supplemented by ordinary matter, neutrinos, and radiation. Inside this universe, we find an embroidery of systems, stars, planets, heavy components, and, surprisingly, shrewd life. In one corner, these grandiose structures all arose through a course of vast development, a striking accomplishment of logical allowance accomplished in the 20th century. Researchers reproduced the timetable itemizing how our universe transited from a generally uniform state, without any trace of mind-boggling structures and principally made out of hydrogen and helium, to the different and complex universe we view today. In the event that we follow in reverse from our ongoing vantage point, we defy the inquiry: how did each individual design or part come into being? Iteratively, we dive into the starting points of every constituent, examining more profound until we experience the constraint of our seeing. Yet, even in the midst of this vulnerability, we think about the beginning of presence itself. Could all that we see emerge from nothing? Life, as we probably are aware it, originates from the tiny particles making the texture out of our world. These particles collect into complex molecules, the building blocks of life, formed from much more modest substances known as atoms. Anyway, atoms didn't emerge at the universe's initiation, maybe they went through an extended cycle of development. This interaction unfurls inside the vast show of heavenly daily routine cycles. Stars are conceived, experience out their divine lives, and at last die, catalyzing the production of new materials through disastrous cycles. These materials, thusly, fuel the birth of progressive ages of stars, propagating the vast cycle. This perplexing exchange supports the conditions important for the development of planets and the perplexing science fundamental for life. For the universe to manifest in its current structure, a few urgent occasions needed to happen. Gravity coordinated the collection of heavenly and cosmic troops, requiring and starting mass that gravitational powers could shape into bigger designs. Dark matter assumed a crucial part in forestalling the dispersal of issue during the initial phases of inestimable development. Besides, a fragile balance of different types of issue and radiation was fundamental for the age of enormous relics like the infinite microwave foundation radiation and the basic constituents of worlds. Vital to this account is the riddle of issue-antimatter deviation in the early-stage cauldron of the early universe. Matter and antimatter ought to have coincided in equivalent measure, however, our universe transcendently includes matter. Different speculations endeavor to explain this uniqueness, including situations where standard actual regulations go through brief distortion, cultivating conditions helpful for issue age. Unmistakable among these is the idea of Sperrin associations within the system of the standard model of molecule physical science. In mulling over the starting points of our universe, we stand up to a significant secret: did the universe indeed come out from nothingness? While vulnerabilities continue, our continuous mission for understanding keeps on disentangling the complex woven artwork of grandiose advancement, testing the demise of presence itself. The universe begins from significant inquiries that push the limits of our grasping. Dark matter, regardless of its elusive nature, is pivotal to how we might interpret the universe. While it can't be made out of the particles portrayed in the norm model of physical science, different hypotheses guess on its beginnings. It could have emerged during the beginning phases of the universe's hot stage, enduring through resulting astronomical sagas. On the other hand, it could have emerged during phase advances as the universe extended and cooled. Different theories propose its presence as a clever kind of neutrino or as an outcome of gravity, giving ascent to astoundingly weighty particles. The question then emerges: for what reason does dark matter exist today when the early universe appeared to work without it? The beginning of dark matter requires critical energy, provoking inquiry into its source. One charming probability emerges from enormous expansion, our driving hypothesis in regards to the universe's pre-Big Bang beginnings. Astronomical expansion places that, before the hot Big Bang, the universe went through a period of fast development driven by an inconceivably high energy thickness intrinsic to space itself. When expansion stopped, this energy accelerated the arrangement of issue, antimatter, and radiation, setting the stage for the resulting development of the universe. Eminently, expansion predicts explicit examples of thickness varieties that line up with perceptions, offering convincing support for its legitimacy. Anyway, while infinite expansion provides a system for understanding the universe's introduction to the world, it invites philosophical consideration. Can we really fathom a state without any trace of spacetime and the laws of physical science? From a philosophical viewpoint, we may consider nothingness as the non-appearance of these principal components. Yet, from a logical viewpoint, characterizing nothingness turns into a complicated undertaking. Logically, we cannot characterize anything in different ways as when something didn't exist, avoid spacetime with negligible energy or the shortfall of the universe and its overseeing regulations. While certain definitions could propose the development of the universe from nothingness, others present difficulties. The thought of genuine nothingness, absent any trace of spacetime and actual regulations, resists regular figuring out. In the domain of material science, wrestling with the development of spacetime from non-presence raises significant inquiries. How could space and time emerge from a state without any meaning of area or span? The conundrum develops when we consider the beginning of the regulations administering the universe. Without a reasonable system portraying presence past our universe, the idea of outright nothingness stays subtle. At last, while logical hypotheses give bits of knowledge into the universe's beginnings, they too highlight the constraints of our understanding. The journey to disentangle the secrets of presence pushes